I was working on a project that needed this sci-fi circuit-like effect, the kind that crawls across a face like the intricate lines you see on chipsets. I honestly thought it would be difficult to set up in Blender, but after digging through a few of the Blender forums and Geometry Nodes manual, I found out it's surprisingly easy with a node called Find Shortest Path. It's incredibly versatile and you can use it for many things like PCB traces, growing vines, insect wings, or even random city path layouts. We'll use it to make this render today, and along the way we'll also go through a bit of the render setup that brings it all together. Let's find out how. This is Ram from CrossMind Studio. We are adding another chapter to our Geometry Node series today. So let's jump to Blender. I have a simple grid plane right here. In the Geometry Node editor, bring one new node network. I'll get rid of this group input and instead I'll bring a grid from within the Geometry Node itself so I can procedurally change stuff from here. Let's increase the X and Y subdivisions to get more resolution. And now I'll bring a selection node called Shortest Edge Path. From the Add menu, I'll just quickly type it out. Shortest Edge Path. So this is sort of a selection node. For this to work, we need another geometry node, which is going to be edge path to curve. This we can plug right in between our node network. And with the help of this, we'll define a selection in a moment. Now you might already be getting the ideas that we need to define start vertices here and end vertex here, and this goes right here. So let's do that. To assign a start vertex, bring an index node and choose any random number. Let's say this number for start vertex and plug that right here. At this moment we can't see anything. We need to complete this setup. Then we'll do the same for the end vertex. Make a duplicate of these two nodes. Choose a different number and use that for end vertex right here. And don't forget to connect the next vertex index from here, from this node to corresponding input in the edge path to curves. As soon as I plug these in, you'll see a curve generated from the grid mesh topology. This curve defines the shortest path between these two vertices. Right now it probably looks like an L shape. That's Blender's default shortest route based on the edge distance. But we haven't touched an important input yet, which is edge cost right here. This is where it gets interesting. I'm not exactly sure of the exact technical definition for this, but the edge cost input some way controls how the algorithm evaluates the cost of traveling from one vertex to another through the mesh. It means whether to take the shortest straightforward path, which is the default, or a more twisted or zigzag one based on what you input here. That means we don't have to settle for this Blender's basic shortest path. We can get creative here. So let's bring some texture here. Let's say checker. Now based on the texture, we have a different kind of path. You can bring any texture. Based on that, you'll get many different kind of results. You can even combine few math nodes to create something really interesting here. Let's say if we use noise texture, if I make this 4D and play with this time value, now the paths will take on more organic wavy shapes. And you can even use multiple start vertices. Let's say if I drag this, instead of using just one selection, just one point, what if we take multiple vertices and combine with Boolean math node? Here choose OR and plug this right here. Now if I change this vertex and define a different starting point, you'll notice now I have two connections. One is this one is this one. And both of these are connecting to this point somewhere here. You can keep on adding more points here. Now you'll see I have this organic sort of a layout. There are many useful scenarios this can be used in. Maybe a city layout, road network, a village layout, or organic shapes. So we have multiple starting points here. Now we can do the same for the endpoints. In the end vertex, what if we combine multiple points? Now we have multiple starting points and multiple end points. So this way, instead of having just one path, we have made multiple random paths, picking up different start and end vertex based on these inputs here. If I disable this texture right here, you'll see instead of one path, which we had earlier, now we have multiple of these L-shaped routes based on different starting and end points. So there are multiple combinations you can try, or you can even disconnect this start vertices. What this will do is, if I disable this and define only the end vertex here, in that case, Blender will treat all other vertices as potential starting points, resulting in sort of maze of overlapping paths, all trying to reach the same destination. So let's say if this was the one vertex. So now everything is trying to meet this point around here based on this selection. If I have multiple points, now all the starting points are meeting these 4 points. Now all of these paths are multiple overlapping paths, basically starting from every point and reaching these common points. So because of that, we have a lot of overlapping going on. To clean up this mess, we'll use the delete geometry node. So let's extend this network and bring delete geometry node. Now we will delete this geometry based on the endpoint selection. Plug that right here. So we just want to trim out some of the starting vertices. So all these paths are starting somewhere and ending somewhere. And some of these are shorter, some of these are comparatively longer paths. What this will do is, it's going to sort of clean up all those tiny short paths which are making this a dense maze. And this will leave a few of these trimmed out longer lines which sort of form a visual of PCB traces. This can be modified further for better results. Now after this, I'll use merge by distance. But since this is all curves, we'll first have to convert this to mesh, curve to mesh. And now this should merge all the overlapping vertices. If you're not sure what's going on here, you can bring spreadsheet. If I disable this node, these many vertices we had because everything was overlapping and there were multiple duplicate splines. Now we have very few because everything else is merged down by this node based on distance. Now we'll convert this back to curves, mesh to curve. So we have some basic setup. Now let's make it a bit more interesting. If I go to the base mesh right here and play with this input geometry in some way, that is going to change the patterns and lines formed here. What if I isolate this geometry and bring one dual mesh node? At this moment, it might won't do much because we either have to triangulate to make this hexagon-like shape, or we can do something better than this. Let's bring one extrude mesh node and plug that right here. Now in extrude mesh, change the offset to 0. And what this will do is, combined with dual mesh, it's going to create these diagonal lines, sort of triangulate the mesh, create a bit more denser mesh, connect in between, and form this kind of geometry. Now let's see how this affects our effect. So this is what we have. Now instead of using noise texture, what if we bring something that works better? In this case, Voronoi texture. Let's make it 4D. Plug this right here. Yeah, this looks much better. So much interesting pattern here. Now previously we had these straight lines because our geometry only had left and right rows and columns. But because of these in-betweens that we have added, extrude mesh and dual mesh node, we have much more diagonal shapes here as well. Now to animate this, try animating the selection input of delete geometry node that we used earlier. We can maybe use this kind of animation. Or if you want to have more control, you can also use trim curve node. And if you plug this texture into end right here, play with map range combined with clamp. And now instead of just trimming the curves, you can maybe do some secondary animations based on textures, trim things unevenly based on map range. And since we used multiple end vertices, what we can do is, if you're not happy with the results, you can always modify the selection a bit to sort of art direct your pattern a bit. Maybe if you're not really happy with this corner, change the numbers a bit, and now you'll have a different pattern. For instance, if I disable the texture, you can see by having multiple points, I can control to some extent how this pattern looks instead of having to settle for what one vertex gives me like this. So this is sort of our complete setup. Now, if you want to go further, you can store a named attribute. Let's say splines. And in this, I'll store the factor of these splines as a different attribute. So what's going on here is all of these splines have this factor assigned, which we can use later on to change the radius of these splines, maybe taper these down, and also in material editor to add some glow into this. So for that reason, we have a stored named attribute. We have these splines, but at the end of these splines, what if we wanted to instance something? Let's say instances on points. If we take this curve and on this, we instance a simple circle and combine that with our main geometry. Right now it's too big, so we'll have to reduce the radius. At this moment, this node is instancing on every point. So what if we use endpoints? And now this should instance only on starting and end vertex. What if I remove the end point or maybe starting point? Now this looks fine, but the thing is, I don't want these circles on the starting point, and I'm trying to remove it by using endpoints, but it's giving me mixed results. So in some cases right here, I have these circles at the starting points. So this node is not helping with that. So what I can think of right now is, what if I simply delete geometry, basically trim these curves down using delete geometry, and I can use spline length. Based on spline length, we can trim down some of these starting points. So if you isolate this right here and this right here, it's trimming these splines down based on length. Now this instancing looks much more directional. It's not technically accurate, but it's pretty simple solution. Now let's see how this will look once we animate this in the delete geometry node. So our effect is there. Now the only thing is, we need to convert this to geometry, curve to mesh. I can bring a simple curve line and put that into profile curve. Reduce the length. Yeah, this looks much better. So this is the whole setup. Now just try and play with some textures, different kind of selections, input geometry. For instance, instead of grid, what if I bring one cube and plug that into mesh? Now the same effect is working on a cube. Or even better, what if we bring one human face? Let's say this one. I already have a geometry prepared for this. Change this to relative and plug that into mesh. Now the same effect you will see working here as well. Now these circles are not really aligned with face. For that, what you can do is just take this geometry of the face and go to the instances on points for these circles. And here, sample nearest surface. Sample this base geometry and we are going to sample normals of this face. And if we plug this into rotation, this should work. We just need to align this rotation properly. And let's plug this into vector, and there you go. We can even subdivide this mesh one more time to form slightly more denser effect like this. And here, if I set material and apply my wires material right here, let's go to shader editor. Let's go to render preview. So here you'll see once I apply material, what's happening here is I have this attribute. In this attribute node, simply type splines, the attribute that we made in geometry node editor. It should be somewhere here. Yeah. This attribute, the stored spline parameter, is working with this gradient map color ramp to create this glow effect. Now I'll take you through the final render file in a moment. So once your setup is done, you can keep on playing with these parameters. Let's say, what if you bring back these starting points? Now you have this. Now by changing this value, you can sort of form a bit of electric lines traveling in between. And a lot can be done just by changing texture. Let's say if I reduce the randomness to all the way to 0 and detail and roughness to 0 as well, you'll see much clearer pattern. All the lines are much clearer now, which is forming better silhouette of the face. And if I animate this value in the delete geometry node starting points, so this is how I started the animation, something like this. So the final files parameters may be different, but overall setup is like this. This is how I started and then animated this value to something like this. And not only in geometry node, you can do many things in material as well. Maybe bring a math node and play with ping pong or truncated modulo. You can sort of create some secondary animations right here. So this is going to repeat your patterns, the spline parameter, and combine that with the, maybe bring one gamma node here to create something really radiant and intense. So it's a combination of both the things, geometry nodes and shade editor, you need to take advantage of and not only rely on just the geometry nodes to form the visual. So here's the final file that I used for creating render setup. It looks a bit of mess, but let me take you through what's going on exactly here. There's nothing much. It's the same face model and a few duplicates of it. The very first thing in the viewport, you'll notice it doesn't match up the render if I render this out. That's because the camera that I'm using is a fisheye panoramic lens. It's not a standard perspective camera. That is why the viewport looks different. In this render, what's going on is if I isolate our effect geometry, you'll see a similar kind of thing going on here, glow and a few circuit-like lines evolving over time. The effect is much more brighter in this one, and that's because after using volumetrics in the background, it sort of dims down a bit. If I exit the isolation mode, on this, we have a simple material, exactly the same setup. I used a splines, curves, call it whatever attribute from geometry node that we brought in. On that, I used a truncated modulo to sort of repeat the lines to create this secondary animation. And after that, a bit of map range adjustment, and this whole thing then goes into hue saturation node. There's a slight shift of hue based on the curve attribute that we have brought in. This whole segment is for just the color of this emission shader. There's an emission shader going on here. So the main part is just this one. After that, you use hue saturation, color ramp, gradient. That's completely up to you. Then you'll notice a different noise texture. This is again for secondary glow, the shift of glow. So the strength of emission is animated based on this W value noise texture. After that, I used a bit of gamma to bump up the intensity of this whole thing. Combined with all the volumetric effect in the environment, it looks decent. And this cube right here have a shader volume scatter like this. So basically, I didn't want you to spend much time in the environment and the surroundings. This was the main focus of the scene. I just wanted to somehow fake the depth and the surroundings. And for that, I've used this volume cube and more importantly, these reflection planes. If I isolate our subject, these are just taking these lines, reflecting it on these cubes and stretching it out. In itself, it won't look much, but in few of the camera shots, let's say right here, sort of adding something so that when the camera moves, it shouldn't be like there is just this head in the background and foreground. I wanted to have this, which merges with the depth of field effect and gives you an illusion of there's a lot going on in the scene. After that, I made a duplicate of these lines, basically the setup, and placed these on the left and right so that when the camera moves, you'll see a bit of motion of these things in the foreground and background. I didn't want it to overdo this. That is why I tweaked this setup. It's a duplicate of the same setup, but in this one, I trimmed down the line much further. And this one, again, a very few lines, slight offset of the same effect, basically. And these reflection planes have anisotropic material, the new metallic shader. Because of that, these lines are stretching in the direction of the plane, and this volume cube is creating this bloom effect around the glowing lines. Wherever intensity is higher, you'll see a bit of bloom glow going on. Now, one last thing you'll notice is there's a deep red thing going on, which is this thing. If I disable this head, which is duplicate of our effect, I mean the main geometry, not effect, it's a solid phase, this one. On this, you'll notice there's a shader. Let me isolate both of these. This shader is pretty simple. It's basically a transparent shader using this bright red or orange color, and then a translucent shader. And based on the layer weight, I'm mixing both of these. I didn't want the inside of the head to just feel empty or hollow, so underneath all the glowing line work of the surface, I added a bit of soft red glow, almost like a translucent layer or energy shield. It's not a solid object or anything, more like a subtle material that adds a sense of depth and internal structure. So the idea was to give the impression that there is something going on beneath the skin, like a futuristic nervous system or power source. As the lines pass through or get close to that red core, they shift slightly in the color, picking up that reddish tint. Even the areas you see through the head carry the same deep red vibe. It makes the whole thing feel a bit less shallow and more like there is some functioning detail, and it's not just the surface or lines or wires. Maybe something which is incomplete yet, but it's still in progress or evolving, kind of a thing. So here's the different file, a slight variation of the same shot. I think this is a good shot for showcasing this effect. Basically, the lines that I've used in the background, these stretching reflection cubes, horizontal streaks, and this translucent shader that we've used underneath the main surface. So you can see the use much better, what exactly the intent of this is, which I couldn't describe with the right words. But I think this visual is a good example of that. Now, another alternate effect, instead of these endpoints or these circles that we have made here, what else you can do is, which you might have noticed in the trailer, there are a few glowing dots which are traveling across the curves. So in that case, I'm just going to get rid of these instances. Just bring a grid or any geometry and distribute points on faces. Let's say 1000 points. Now to preview this, bring a join geometry node at the end or one before the set material and combine it with our original network. Now you'll notice these points on a grid. Just set point radius and make these reasonably small, like 0.001. Now we need these dots, which are hardly visible here, to travel on these lines. And we discussed this in one of the previous chapter. You can watch this full tutorial from the same geometry node playlist. What we need to do here is sample curve. We need to sample this curve, original curve that we have. And in this sample curve, we are going to change this to vector. We are basically sampling the vectors of these curves. Enable all curves. We want to sample all these curves and change this to length. Now we can use this position, which is basically the positions of these curves, to set position our points. If I set position here, bring a node and take this position and apply it. For preview purpose, I'm going to increase the radius of this point just for now. Now you can see all these points are traveling on these curves, but everything is stacked on top of each other and overlapping. We can't really see random variation. So for that, just bring a random value node and increase this range. And now you can animate these numbers in any way you want. And these will always travel along these curved lines like this. All right. That's about it for this one. Just an optional thing. This is what I used for the trailer files. So that's it. This is one of the simplest yet most flexible setup you can build in geometry nodes, and the result looks great for the amount of effort involved. You can download the project files for free. Links are in the description. And by the way, YouTube doesn't always show the full playlist. So if you are new to geometry nodes, check out the previous chapters in the series. And if you're a beginner, completely new to geometry node, I would suggest that you watch this series in correct order to make the most out of it. And some of the nodes have been changed in geometry nodes network. That's completely all right. I have mentioned those changes in pinned comment and description, so you won't have trouble following along. And this series is still relevant to the current version of Blender. And also, if you're just starting out with Blender, our free beginner series, which recently crossed 5 million views, is still one of the best places to begin learning Blender. And if you're looking for more in-depth content, check out my premium courses on Gumroad and Super Hype Market, which was previously known as Blender Market. They are on sale and a lot of students have found them super useful. You can see the students' work here as well. There are plenty more useful playlists on this channel as well. Be sure to check those out. I hope you enjoyed this chapter. I'll see you in the next one. Have a great day. Thank you.